Here in the Faculty Club and those online at home. Welcome once more to Senior College and another Wednesday morning lecture. This morning, Bibhu Mohanty is going to introduce our speaker. Bibhu.
Good morning, and thank you very much for coming by. When I saw the title of the talk and the author's biography, I volunteered to introduce him. You might wonder why an Indo-Canadian is interested in Nunavut or Inuits. I'll explain that in a few slides after the intermission. Anyway, we have a renowned scholar, not just in chemistry, but also in, how would I say, chemoanthropology. He's a fellow of the Royal Society of Canada and has written marvelous books. And his book in chemistry has been translated to at least half a dozen languages, in half a dozen languages, including Khmer. I didn't know that. Anyway, so he's a professor emeritus in Newfoundland, and after he became a emeritus, he had two Inuit students who tried to connect chemistry with life of the Inuit. And this is, I'm not going to spend any more time on it. I have a couple of slides after his talk, but we are very glad and honored to have him as our speaker. Thank you.
Good morning, everyone, and thank you for the invitation. It's a great honor to be here. So to start with, I really, as was alluded to, must recognize my two, whoops. There we go. No, it should work now. Okay. My two co-researchers and co-authors, Chaim Christiana Anderson and also Rosalina Nakitovic. And this would not have been possible. I was like the coordinator and the compiler, but they were the ones that really made this happen. So first of all, the acknowledgement, which is so important. I wish to recognize the Inuit Tapirit Kanatami, which means the Inuit are united in Canada. 65,000 Inuit across the four recognized homelands, Nunavut, Nunatsiavut, Nunavik, Inuvialut, and across the rest of Canada, and especially acknowledge the many, many wrongs done to them and thank them for their hospitality. When I've been on Inuit lands, the hospitality has just been unbelievable. So why the Inuit? And first of all, and I hope if some of you probably know much more about this than I do, the migration routes for the Inuit and their predecessors, the Thule and the Paleo-Inuit, were quite separate to those crossing more southerly routes. And so the routes across the north led to a completely different culture, which depended upon ice, depended upon on what the north could provide, even though it's very, very cold. And the people living there have genetically adapted to that, as well as come across. But the key thing is, but for chemistry, Inuit survival of the north would have been impossible. It's just that it was so underlying, people just have taken it for granted. So just a refresher in what we're talking about. So this is Nunatsiavut, which is the Labrador part of the Inuit homelands. Nunavik, which is the northern Quebec part. Nunavut, which is a whole self-governing territory. Inuvialut, which is the part of Northwest Territories and the Yukon. And the contested at the moment extension further south of Nunatakavut. But people don't realize 35% of the land area of Canada is Inuit lands. 35%, 1/3 is Inuit lands. And the geographic center of of Canada actually is Baker Lake, which is there. That's the geographic center of Canada. So we're talking about an enormous part of Canada. Now, the other thing that interested me was the extent of Inuit going south on the east coast, because that's been forgotten, the Nunatavut. And the first record of Western record was 1588, Inuit woman being killed at Carpoon. Yes, not Kirpon, Carpoon, according to Newfoundland accent. Then 1716, about 400 Inuit living in Forto, about the same number on what is over the border in Quebec. Living in around St. Barb in Newfoundland. In fact, there's a museum in Rocky Harbour which has many Inuit artifacts have been found there. And as far along as Mingan, Quebec. And big settlement at St. Augustine, Quebec. I was visited there, and that one of the interesting things was most people in the community can trace at least one Inuit ancestor in this community. And the other thing which is it's a continuing learning curve. I visited Cape Ray, and there's a museum this is right down near Port aux Basques, southwest corner, and there's a Paleo Inuit summer camp there, and all the artifacts from that. So the Inuit spread very far south on the east coast. So how did I get involved? I did outreach to schools and all over Western Newfoundland, into southern Quebec, up into Labrador, and actually even across Nunavut. And this is one example. And one thing that I found was the particular interest among Inuit students questioning. Well, you can see the picture there. We thought that these little kids in the front row were going to get decapitated. They were just so intense there. And in the Nunatavut, similarly, and that's Chame there, but in a multicolored lab coat. And so this is why I developed, because I got good response all over the schools I went to, from Western Newfoundland, all over. But the Inuit schools, the students were so inquisitive. There's so many questions. It's always like, my plane's about to go. I'm sorry, I've got to leave now. I've got one more question. So as I say, that one on the left really conveys the enthusiasm for chemistry. And just to mention, this was supported by the Grenfell Campus and Memorial, NSEC Promo Science, and the Chemical Education Fund of the Chemical Institute of Canada. Thank you, Judith. So in the last couple of years that this was happening, 2017, 2018, we had a student start doing chemistry who was an Inuit from Nain, and her name was Chame Christiana Anderson. We put the Christiana in because when she just put down Chame Anderson, everyone said, "Who are you?" "I'm Chame Anderson." "Oh, we're expecting a guy." So I had to put the Christiana in to make sure that she got a room. And because when you do this outreach, you chat away, because you're sitting in a horrible old Grenfell van for days at a time, going up and down, visiting schools. She said, "There's so much chemistry in the way of life that I have. No one seems to have documented it." So I said, well, we're going to fill that. We're going to work on that. And so between us, we wrote some articles for the University of Waterloo High School magazine. And that's one of them, Snow Making Life Possible in the Arctic. And so we wrote a series of these, and then Chame moved on in her life. And I thought, oh, that's it, we're never going to complete this. And it turned out to be a blessing in disguise, because she had the perspective from the Nunatavut in the east. And then, as I mentioned later on, I got teaching for Nunavut Arctic College, and there were many brilliant students, but one stood out, and that was Rosalina Nakitovic. And I emailed her, said, would she be interested in co-authoring these other remaining chapters? And she'd love to. And this finished up with this whole issue, which was so grateful for the University of Waterloo to publish 72 pages of all about life and its relationship to chemistry in the North, with the reminiscences and the contributions and the thoughts of Chaim and Rosalina from the two perspectives. So I cannot thank them enough. It would never have happened without them. So now, working up in the north is a constant learning curve, the steepest learning curve I've ever been on, more than chemistry. And the first thing is that you think there's Inuktitut, but no, there's all sorts of different languages and different dialects. And so this gives you a perspective across the north. So we start off trying to, when I was teaching up there, put some Inuktitut words in. It turns out they were South Baffin Inuktitut. We finished up and go back to English because some of the students couldn't understand a word we put. Inuit students couldn't understand a word of it. The other thing was that in the eastern side, that the missionaries taught the Western alphabet. So that's the bottom one there on the stop sign in Iqaluit. But the missionaries in the west half, they use the same syllabics as they use for the Cree. And so that you've now got a difference in language, but also the written word. And just a very quick intro to the Inuit language. Inuk is the word for one Inuit. Inuuk is for two, and Inuit is for greater for two than two. So periodically you see words sprinkled throughout my presentation, and sometimes I've just gone with the general one, sometimes I've gone with the one for one, but yes, more steep learning curves. This is now on to our first topic, which is the chemical uniqueness of water. Because, and don't worry, before you run screaming, this is going to be only a little bit of the chemistry that comes in here. Water is so different to what you'd expect, okay? Water, as you know, under ordinary atmospheric conditions, melts at 0 and boils at 100. But if you look at the pattern in the elements beneath it, that water should actually melt at about minus 100 and boil at about minus 90. Can you imagine? That would, the oceans would all have absolutely vaporized. We'd be living in a climate of water vapor. So why is this? And it's back to chemistry, because water molecules are attracted to each other very strongly by what's called hydrogen bonding. And this holds the molecules together much more strongly, so it needs much more energy to break them apart. And that's why water is exceptional. And this is obviously the key component to survival in the north, is this quirk of water, is this hydrogen bonding that makes it so exceptional. So the igloo, just a brief mention of that, is that it's very cleverly done, because another part of chemistry is that as gas molecules become hotter, they're moving faster and the density is lower. So the passageway into an igloo is down lower. So the warm air is trapped inside. If you had it all level, then the warm air would leak out through the entrance. So it's so structured, so it holds that warm air in place. Now, before you think that this was ancient history, this is Iqaluit just about 5 years ago. And these are kagiks. These are large ceremonial ones. It boggles my mind how these are built, because I've got a picture of one which is just enormous, probably in girth about the size of this room and about as high. Just how on earth that these are still built, but so they're still part of the ceremonial. But the other thing is that Inuit didn't always occupy igloos. They did in the far north back in the day, as we say. But this is a wooden house, and this is about 1900. And even Chaim can remember, and she writes about it in her reminiscences in one of the articles, that she and her, when she was young, and the other kids around that age, would see how quickly they could pile snow around the house, because they realized that snow, because of the crystals trapping air inside, were very good insulation. And we think this might have been one of our ancestors, because this picture is in the early 1900s, was taken on Okak, which was the island where her relatives first came from, until Spanish flu wiped out most of them, and the rest were forcibly resettled. So so snow, as well as being for building materials, is also used for insulation. But the irony is, if you go to Newfoundland these days, and in the middle of winter, what do people do? They shovel snow away from the houses, which is insane. Okay. The other thing is the transportation aspect, and this is shame hunting for seal. So it's going out on ice is such an important part of the food supply, the country foods that they rely on. And she sent me an email some years ago saying she got her first seal with a 202. And then she sent a picture of it. And this is Rosalina fishing with Arctic char. So the ice is absolutely vital to the way of life. And again, it comes back to this hydrogen bonding and for transportation, because this is the only way Chame and her daughter could get back to Okak and visit where her relatives came from. Atmospheric chemistry. I'm zipping you around here. So atmospheric chemistry, what's this got to do? Now, when around here you don't see aurora very often, you see some a bit further north, and you say, oh, that's nice, green, maybe red, maybe blue, that's pretty. But if you live up where Rosalina lives, that's the image midday in midwinter. So absolute blackness. So when you see an aurora, this is something that really is uplifting. If you suffer from seasonal affective disorder, it's just total pitch black from the beginning of December right through to the end of January. In fact, when the sun first peaks over the horizon, this is the day of celebration. School's cancelled and everyone goes out and celebrates the return of the sun. So, but the aurora in the winter is not just pretty in the sky. This is something that's uplifting. And there are children's books written about it. Now, there's so many things that I, as a non-Inuit, ask questions about, and I'd never get an answer. One of the things that Inuit all across the north know, the children, is if you whistle at the aurora, they go away. No, it does not happen. But the latest one is that if you raise your zipper on your jacket up and down rapidly, it goes. They said, oh, we've always done that. I said, no, zippers haven't been around for always. Zippers only been around for a few decades. We've always done it. But so this is one of these things I don't know. And again, all the way from Nain to Cambridge Bay, they all know about the zippers up and down, and they always seem to go further away. So this is chemistry, because the origin of the auroras is that you've got these charged particles coming from the sun, these intense particles, and they follow the lines of magnetic force around the planet, and then some of them leak through to the poles, and where they impact the molecules of the upper atmosphere, this is what causes the color, because impacting the atoms, it raises the electrons from the ground state to an excited state, and then when the electrons fall back to ground state, they emit either green or blue or red. So again, it's chemistry. Now, this is the downside of chemistry in the Arctic. You all know about distillation. Some of you have been forced to do distillation in the labs. But the planet is a giant distillery that in the warm air, in the warm parts, that molecules migrate to cooler, just like in a distillation apparatus. And one of the molecules that's a real particular problem at the moment is these PFOSs, these perfluorooctane sulfonic acids and the related compounds. These are produced in the States, for example, for making Teflon. And it's been known, but covered up by these companies, that these are very toxic, that they stay in the environment. There's no mechanism for their destruction. And if you look at the populations, the distribution in seals, which is one of the primary food sources, you can see horrendous levels of PFOSs up in the Arctic, because they've vaporized down around Pennsylvania and all these factories down there, New Jersey, and then migrated up to colder climates in the north. And it's a serious problem up there, is health issues related to PFOSs. The ulu, which is unique to Inuit, is another topic. So I'm flitting over there's many gaps in the presentation are filled by articles in here. I should take this is all distributed for free, but by the way. Oh yeah, that I sent a copy. There's a link that you can get a link to the online version. The online version is hard to read, but I forwarded a copy of the PDF, and the PDF is just like this. So the ulok, which is the singular, is handed down generation to generation. This is one from James, and it was her mother's maternal grandmother. So you can see the generations this was passed down. And more and more of the students are trying to resurrect this. When I was talking to them in class, they say, oh, yeah, this is a good idea. I'll make sure my grandmother's gets handed down to future generations. And it's still used. This is Chaim scraping flesh off a seal skin. And this is Rosalina chopping frozen caribou with an ulu. And when you think about it, it's the smartest type of knife, because what do? We have a knife that's like this. So we put stress on our shoulder, we put stress on our joint here, we put stress on the joint there. But if you're putting your whole weight down, then it's a lot better. You've got less strain on your system. Now that's a metal one, that's an iron one. And they're unique to Inuit. If you find ulu up north, Inuit have settled there. And this is I'd love to know the age, but it was just on the blog of the Library and Archives. I think by the look of it, from those holes in it, it was possibly a slate ulok, because before slate was the standard one. The slate was a rock that you can slice into thin slices, and it's fairly hard, and you can make an edge on it. So this dates back to about 1700. Now, in the Western Arctic, you could find copper on the ground. This is a lump of copper that found on just on the surface, because copper, as any chemist will tell you, does not rust like iron. So it just stays there like that. And over the Western Arctic, this is commonly found. So on Western Arctic, you actually find copper-bladed ulok, and this dates to about 1800. Now, iron, you would think, would only come when contact was made with Europeans who had access to smelters. But in fact, there was iron in Greenland, and it was a meteorite that fell around Cape York, and about 20,000 years ago, very large fragments. This is the largest of them. And this is Robert Perry, the explorer, with a meteorite in 1897. And this is an ulok from the meteorite, date unknown. I suspect with the wooden handle, I could probably at least date the wood and get an idea, but I don't think anyone's done that. So how do we know the iron came from a meteorite and wasn't brought over from Europe? And the answer is that this iron had a unique composition. It had very small amounts of chromium-3 nitride in. If you find an ulok with chromium-3 nitride in it, bingo, it's come from Greenland, okay? And this is one thing we'd like to know, is how far the trading went. And I was up in the Nazi just 2 weeks ago, and I gave a talk to students there, and the social studies teacher said, hey, this is an example that we use on trading across the north, the extent to which iron uloks have been found way across as far as Hudson Bay. So we know at least across into Canada, at least 1,000 kilometers. We'd love to know more. How many people find an old rusted bit of iron on the ground and say, oh, it's a rusted old bit of iron, and throw it away, and don't realize that this was probably a very important way of tracking how far this was done. Now, if you go to Greenland, look for this, you will not find it, because the Americans stole it, okay? This is now in the American Museum of Natural History. The Inuit in Greenland grieved because it was a sacred object, apart from being the source of this important metal to make ulu for hundreds of years. And here is one of the smaller pieces. It's one of the 3 big pieces. And the students up in the Nazi are so incensed about it that they are actually putting together a petition to reclaim it back for Inuit lands. And I just hope it succeeds, because in the blurb in the American Museum of Natural History, there's no sense of the importance to it. It's just a meteorite found in Greenland. There's no sense of the importance to Inuit culture. There's no sense of the importance to Inuit way of life as being a source of iron for centuries. Maybe it can get you all to sign the petition. But seriously, it really, of all the artifacts that need to be returned to the people that own them. I know there's a totem pole recently been sent back from Scotland to Western Canada, but this I think is just heinous crime to have stolen that just wasn't cultural, but was the source of iron. The Inuit diet, this is something, you know, people tend not to think about. How come the Inuit could survive in the north? Because we know when the Western explorers went there, that they all died of scurvy. Every one of them, well, I shouldn't say every one of them, but large number of Western explorers, European explorers, died of scurvy. And of course, it's vitamin C that's the crucial thing. And the major source has traditionally been raw seal liver. Seal liver contains very high levels of vitamin C. But if you cook it, it destroys the vitamin C. So raw seal liver has been one of the major sources throughout the year of the vitamin C for the Inuit in the traditional diet. Arctic char has been another mainstay of the diet up north. Now, one might wonder why Arctic char, why isn't char everywhere, just like salmon and brook trout, everything? Because the Arctic char has a very high metabolic rate, and it requires on very high levels of oxygen in the water. And the solubility of oxygen in the water, getting to chemistry again, is inverse to temperature. And Arctic char have to have at least 12 milligrams per liter of oxygen in the water for them to survive. If they try and travel into warmer waters, they literally suffocate and die. So the Arctic char literally can only live in the Arctic. And they're so important because they're very rich in omega-3 fatty acids. All of the salmon family are, but this one's particularly rich. But if you look, that the area they can inhabit is way, way up in the around Greenland, the northern Arctic. And as the seawater's warming, then they're going to have a more and more restricted range over the decades to come. Now, as every Inuit child will tell you, the best way to eat Arctic char is as pitsik, the dried raw Arctic char. This is so you see outside Inuit houses, you'll see these rows hanging from washing lines and things, and there's a young woman holding up the Arctic char. But this is eaten with, as any Inuit would tell you, soy sauce, which has been used always. And I say, but soy sauce isn't something you find in the Northern Arctic. Someone must have bought it from Japan in the first place, or China, but we've always had it. So this is true again from Nain to Cambridge Bay in all my travels. Now, the sad thing is that the one that you get in the Arctic is not kikkoman, but VH, which if you read the label consists of caramel coloring, soy extract, vinegar, preservatives, and glucose fructose. So the natural soy sauce contains vitamin B. It's really healthful. The sodium's a bit on the high side, but instead they finish up with a product which is rich in sugar, which is rich in salt, and is not good in the diet. But it's so funny everywhere. Oh yeah, soy sauce. It's like, no, you haven't had it forever. Trust me. So, but as far as people's memories go, it's always been in the north, all the way across the north. And a good question I was asked was, does that apply to Greenland and the Alaska Inuit as well? I don't know, but that'd be an interesting question to answer. If only we could find records somewhere of like some Japanese or Chinese adventurers went north in 1920 or something, conveyed it, but it spread so rapidly. It brings us on to the main part of the Inuit diet. And seal has obviously been the mainstay, as I think most of you are aware. And the Inuit diet consists of protein and fat, no carbohydrate. The perfect Atkins diet was for Southerners, but they've adapted genetically to it. So this is something that comes naturally. And so you can see in the blubber of seal, there's all these unsaturated fatty acids. Then there's Arctic berries, where you can find Arctic berries. And then there's Canada geese eggs, which Rosalina wrote about from the very earliest stage. I can't believe, like 3-4 years old, she was sent out to collect eggs. And we're taught not to gather all the eggs from the nest. We had to leave 1 or 2 eggs so that the geese will continue to return north. And Shane remarked how seabirds, they have lots of seagulls in the Nunatsiavut, and from an early age she was sent climbing the slippery cliffs to get seabirds' eggs. Inuit remedies. When you live up there, there's no Shopper's Drug Mart around the corner. And so one of the things that you find out, there's dwarf willow. And as I think a lot of you know, that the willow was the origins that was adapted into aspirin. The dwarf willow is found up north. And as many of the Inuit students in Nunavut know, that if you chew on that, it'll remove your toothache. And it's a known remedy because it contains salicin. So a lot of, I don't know about all, but a lot of them was actually got strong scientific basis. And this certainly, dwarf willow contains a relative of aspirin and will indeed act as a painkiller. This is not in the Chem 13 news because never found out about it until too late. And Rosalina knew about it, but she never thought to mention it. Puffball. This is a type of mushroom, and it produces an antibiotic which has been recognized by the National Institute of Health. And so when I was in Nunavut, I said, well, go out on the land and hunting or whatever. They said, oh yeah, we know we always take some powdered puffball in a little container with us. So if we get a cut, we always apply it and it always heals up well. Arctic minerals. This is a whole topic in itself, but silicates, these are the very oldest rocks on the face of the planet. These have been there for billions of years. So this is from taken up in the Arctic, 3.8 billion year old greenstone, the silicate rock. Now, some of you have heard of these. These are the Inuksuk, and there's Rosalina sitting on top of one. Now, these were not done because of creative, artistic. These were done to navigate. When it's snow and ice, it's snow up there, the only way you can find your way home is by knowing which shape of Inuksuk is on the cliffs and which way to go. So these were big and they're enormously important. Some of them, that the memory is gone as to why they were in a particular location. This one is near Pond Inlet, and it was used to navigate from the ice back to where Pond Inlet was located. And it's commonly thought that Inuksuk are the ones that are like people, but it's not. These are Inungiwak, and there's one there, and they serve different. These were more ceremonial. The one that Rosalina was a true Inuksuk. These were the things because they're made of rocks which survived 3.8 billion years. They're going to be there forever, and so these are very important. And the flag of Nunavut is actually of an Inungiwak, as is the flag of Nunatsiavut. So these are, so it's a very core part of the culture there. But these days, everyone has GPS, and so so I think these have become more and more just of historical importance. But for thousands of years, this was the way the Inuit who went out hunting on the ice could find their way home, was by recognizing the particular shape and knowing which way would get them back home again. And it's silicate rocks, and it's because they're silicate rocks, they last forever, and it's the chemistry. Soapstone is equally if not more important. And soapstone were the vessels that they made for bowls, for lighting, for filling with seal oil, lighting for heating, for cooking. And it's the crystal structure, as you can see, is a layer structure, and that's why it's softer. You can shape it. There's no way you can shape granite. Well, you can, but it's very, very difficult. And in fact, this is very, very important. This is the esteemed elder Mary Pudlat lighting a kullik. And this was when Nunavut was actually made into a self-governing territory. And it's something that's really part of the spiritual life of the Inuit. And Rosalina remarks how she was chosen to light the ceremonial kullik at a couple of events when she was in school. Clothing, and particularly the women's clothing, the Mohanty, because we tend to forget clothing is chemical. If you said, take all the chemistry away, we'd all be stark naked. Actually, we wouldn't even exist because we're all chemistry and biochemistry. But the clothing is amino acid chains which wrap to form collagen triple helix, which then combine together to form the strands that we know of as clothing. And this is the women's clothing, and this is the one with the hood. These were two students in school in Iqaluit, and they had their babies in the back. And you notice that instead of the traditional brown color, which was the only coloring that the Inuit originally had, now they've been taken over, and this is now something where we really show off the bright colors. So this is incorporating Western dye stuffs as well. Loving the brilliant colors. Well, it's still decorated with fox fur and seal skin. So the basis is still the original materials, but it's been redecorated. Again, Rosalina refers to that and the importance of the Mohanty. And here's Rosalina on the right-hand side. So in graduation from middle school, that all the Inuit young women all wear these special Mohanties for the occasion. And waterproof materials. They had waterproof materials, and this is a girl's seal gut waterproof parka made from seal gut. And as any chemist will tell you, that there's two types of materials. They're hydrophobic, ones that repel water, hydrophilic, which love water. And we can explain that in terms of the bonding. There's a water droplet, and the surface is non-polar, and so the water molecules just run off it. But the superb stitching in that, when you think that's made of seal gut, just astounding the quality of the construction. You wonder how many hundreds of thousands of hours went into making that, and doing it so carefully and with the matching stitching. Bone is another important material, and one of the components of bone is calcium hydroxyapatite. Don't worry, you won't have to draw this on the test that follows. But the bone needles and walnut tusk case are both made of bone. And again, when you think about it, needles were so vital. You can't make clothes without needles unless you just wrap yourself in an animal skin. And so all these were carefully made. So first thing was making the bone needles. And as well as the kayak, which is everyone knows about the kayak, that in fact the larger ones were the umiaks. And this was, the women students, when I talked about this, got a great laugh out of it. So the guys get to enjoy themselves in the kayak, and we do all the heavy lifting, conveying the tents and the food to the next camping location. Huh. Same old, same old. And one of the teachers in Hopedale, and they're starting to actually make original umiaks. And they said what they should do is, just like the Chinese have the dragon boat races, why not have umiak races? And Hopedale Bay would be wonderful for having umiak races. So she said she's definitely going to look into that. But yeah, people never talk much about the umiak. One of the things is that I love about the Inuit people, well, love is a bad word, sorry, that I respect the Inuit people for, is the adaptation. It's not a dead culture. I mean, if you go back, my history growing up in Kent in England, you know, we have these Morris dances where everyone goes out with tinkles around. Very nice. So that's it for the year. Now get on to modern life. It's a fossilized ethnic origin. But in the north, the Inuit are always adapting. And so the ski-doo, which is actually should have been called the ski dog, this was a typo. It's true. This is a typo. It's supposed to be the ski dog because it replaced dogs, okay? Which makes sense. Do makes no sense at all, okay? It was ski dog. And this is the early one. And one of the things that, again, I'll come to it in a minute, was that you need special oil because regular oil is going to freeze solid in the Arctic. So the students that I taught said, hey, who's wondered that? My parents said, as soon as we get the snowmobile from the south, first thing, drain the oil, get the oil out and put in this special oil. So special oil has to be created for the north. And this has become so part of the culture. There's Inuit mom taking children to school, and there's Inuit children in the komatik, the trailers. And the ulu have become adapted, and rhubarb. So ulu are now made from discarded circular saw blades because the steel is really high strength steel. This is perfect for making something you want to maintain. And here's a completed ulu, and there's a YouTube video, of course, on how to turn your discarded circular saw blade into the ulu, which you can then quite often sell to tourists and use yourself as well. Rhubarb, this was brought over by the Moravian missionaries to Nunatsiavut, and the Moravian, and this now grows wild in Nunatsiavut, and has become adopted part of the diet. The same old, same old. So how long have you been eating rhubarb? We've always been eating rhubarb. And it now is adapted. I don't know, you tried growing rhubarb, but you're supposed to put manure on it. This stuff goes wild up there. And it contains vitamin K. And all the little students, including James, said, oh yeah, you take it raw and you dip it in sugar and then you munch it, which is exactly the same as what my wife did back in Manchester, in England. So, snow blindness, okay? Real problem is, as you know, that it's just white. And these are the traditional bone, again, chemistry, snow goggles, because bone you can work and fabricate. They've been turned into some wonderful art objects, as well as being very practical. But then, this is in a magazine called Them Days, which is all about life in the North. And they've adopted orange oil as a treatment for snow blindness. And it's, in fact, it contains the terpene limonene, a known anti-inflammatory. And the Inuit or Inuk said, as one Inuk commented, not truly traditional, is it? But it works. So it's now become the thing that is to get orange oil if you are worried about going out in the middle of winter and you are worried about getting snow blindness. Climate change, we know about that. And of course, this is all to do with chemistry. If you were told that the carbon dioxide molecule looks like that, your teacher lied to you because it's in constant motion. And the more infrared energy it absorbs, the faster it goes and the higher the temperature. So climate change, it's all to do with carbon dioxide and methane, but it's all to do with the chemistry. And by the way, this was first observed by Eunice Newton Foote back in the 1800s, but she got written out of history. But that's my talk on women in science. So this is the most scary thing in the North. The Inuit from coast to coast are worried about it because you can see how the ice is getting smaller and smaller. The temperatures up north are getting higher and higher. Shane was saying about places that she used to walk. She can't walk with her daughter because they're so overgrown. The trees are everywhere now. And as I said, the Arctic is ruled by ice. For Inuit, is the platform on which life is lived. They need ice and it's going. The ice is melting, becoming dangerous. So many snowmobiles going through the ice. In fact, when I was up there in the airport can't call it a terminal. It's a shed where they keep the snow clearing equipment. There's a big sign up saying, you know, take out one of these harpoons and check the ice and make sure that you've checked it, because so many people are dying from falling through the ice now. So this was the publication that came out. There's Rosalina with it. And this has been sent out to all schools across Canada. And this was on X, formerly known as Twitter, posted by one of the school teachers in Ontario. But what it led to us doing was to take this back in turn to Inuit students. So Rosalina and I got together in Iqaluit and put together this presentation. And I took it to students up in Nunavut. Pangniatung, Nunavut was that picture. And 2 weeks ago, I was at Nain in Nunatsiut. And these are the comments I got back. This is from Pangniatung. I'd like to thank Geoff for bringing such a detailed presentation to our community. Information shared provides insight into how chemistry can be found in everyday lives, especially shed light onto how chemistry and Inuit life are woven into another. It was a pleasure to be able to provide us Inuit students with lessons through which they can find meaning and see themselves in the material. This is why it's so important, I think, because it's full circle now. Inuit students, instead of thinking of chemistry as something that happens in chemistry labs, is boring and full of calculations, that this shows the links to their lives, and it cites them about science, and hopefully we'll get some doing science-related careers. And this is from Makovic, from my visit a couple of weeks ago. As an Indigenous school, great importance to include learning opportunities, both engaging and culturally relevant. Your presentation successfully showcased how chemistry could be incorporated into the Inuit way of life. Amazing to see the high levels of engagement, particularly with our younger students. They remained inquisitive throughout. I told you that, incredibly inquisitive. The entire presentation, important skill pertaining to scientific literacy. So that was that avenue. And we finished up getting a national award by the Society of Chemical Industry Canada for this work. Now, the last part of my presentation veers off in a slightly different direction. Memorial University proclaimed a strategic framework for indigenization 2021 to 2026. And myself and my co-worker, Debbie Wheeler, we devised a course called Chemistry in Everyday Life. And we thought we could put some of this Inuit material into chemistry in everyday life. So this is, my life is full of weird happenings. I don't believe in divine providence, but things just sometimes are weird. So we discussed that we were going to do this. And 3 days before the beginning of the winter 2022 semester, we get an email from Nunavut Arctic College saying they heard we had a distance course on chemistry. Their B.Ed primary elementary students desperately needed a science course. Could we put it on for their Inuit students? It's like, well, are we going to get a trial by fire or what? So we were writing this desperately 1 week ahead of the students getting it. And so this is the course, Chemistry in Everyday Life. And this is Debbie Wheeler, who's the co-instructor. And we have an activity kit the students do. So they actually have hands-on activities. We can't call it a home labs because 2 things. One, then they have to do a prerequisite online course with Memorial University on how to put out sodium fires and all sorts of things that terrify students. And plus it scares students who always say, with a lab, no way. Okay, so this is a course with activities. It gets us away both ways. They don't have to do this bizarre stuff, and it attracts the students. Anyway, so Nunavut Arctic College. So this is the comments that we got back from, oh, did I miss this slide somewhere? Oh, there we go. So I missed that one. So this has 5 campuses across Nunavut, expanding incredibly rapidly. It's the largest post-secondary service region in Canada, one of the largest in the world. So we taught it. These were comments back from our Inuit students. My immediate reaction to chemistry course was nervousness. After reading the course materials, all the introductions, I'm extremely thrilled to begin this course, and I'm pleased that Inuit culture will be included. I'm excited about taking the chemistry course. This is from students who've never taken chemistry before. Maybe ignorance is bliss, especially because our Inuit culture will be incorporated. Our Inuit culture and tradition are very important to me, especially our language, so I'm happy they will be incorporated. I wonder who wrote this one. I can't wait until 10:30 p.m. because this is Eastern time. So I'm started on this checkpoint activity week 10. I love this Chem 1900 so much. I'm so upset it's coming to an end soon. Well, who wrote the later articles for this one? As soon as I saw that, I thought, I know who's going to write these articles. And then finally, I want to show appreciation to instructors for trying their best to put Inuit relevance in our week's content. To me, it shows we appreciate students. I love it when us Inuit in our culture feels included. Tremendously positive feedback from every week, this section on relevance of chemistry to Inuit life and culture. So we continue to have it for our memorial students. And we get comments like this. I believe that having the Inuit features incorporated each week's reading is a great way to honor the Inuit culture in our country. They provide interesting examples of how chemistry is all around us, but it's also an opportunity to learn more interesting facts about Inuit people and their culture. The Inuit features quickly become my favorite part of the weekly course readings. I can't wait to learn more in the coming weeks. As Debbie and I discussed, I think we should rename it the Inuit Relevance course with some occasional chemistry, because this is what they all seem to go for. Inuit features, of course, are very important. I think learning about Inuit culture is central to us as Canadians. These courses allow us to understand specific aspects of Inuit culture and life can be related through chemistry. And so thank you to you all on behalf of Chaim and Rosalina. I can't say enough, but just to illustrate how different some of the words are in different dialects and different parts of the North, these are the thank you words from the North Baffin dialect, the South Baffin dialect, Kana and Matna, which is a separate language, and from the Natsiavut dialect. So thank you so much for having me.
Thank you so much, Geoff. We're going to take a 10-minute break.